Ladies and gentlemen, in this poster presentation, I would like to talk about maze solving visualized by long-path microchannel plasmas and reproduced in reinforced learning model. So this is OsamuSakai coming from the University of Shiga Prefecture, Japan. Maze solving is very attractive scientific topics, and first of all, mathematical analysis is important, and there are several research methods. And today we focus on the analogical solving by such kind of physical or biological phenomena. In our case, we would like to solve not using such kind of biological method, but using plasmas. There is one previous report who handled the method of image solving by plasmas. In our study, we'd like to use such kind of very small cross-section microchannel plasma, which is generated in a 1 by 1 millimeter cross-section. So there is an electrode and there is a gas inlet holes, and there are one pair of electrodes between this and this, and we apply the voltage, bipolar pulse voltage like this. And so I can say that it's not a microplasma, but the cross-section is very small. So as an experimental results, we can say that when we apply the voltage and when we set the argon gas at 300 pascals, we can see such kind of ignition of the plasmas, and also extension to the pulse to the shortest one, and finally the extended microchannel, micro-long channel plasmas arrived at the goal of the maze. This is actually reproduced by our newly developed method using the reinforced learning. So briefly, I would like to explain how to calculate such artificial intelligence-based calculation. So initially we set reward to the kind of structure similar to the case of the experimental setup of the microchannel arrays. And here we set the reward to the edges next to the goal node, and we iteratively calculate profiles of the active value function, which is defined like this in this equation. And here we think about current state action and current reward which can be obtained, and also set the learning rate and discount rate. And finally, after a summation of the Q values, we select paths with a maximum value of them at each node and go forward, and we can get a successful like this successful short path channel similar to the case of the plasma generations. In summary, we find a short path by generating long channel plasmas, and it can be reproduced using the reinforced learning method model. Thank you for attention.